We are talking about end behavior of rational functions. Now, notes are a little bit weird, so I'm just going to be jumping around. Just pay attention for the most part. Copy down when I tell you to copy down. Okay? Do you guys remember end behavior of polynomials? Are you sure? Yeah. Are you positive? Or are you negative? Okay, so if I gave you this function, negative 3x to the fifth minus 20x to the fourth plus 5,000x. What's the end behavior, and what does end behavior mean? Like, what do you know when you talk about end behavior? Go.
End behavior is up down. End behavior.
Not, you don't know it's that specifically?
That type of thing.
What's the y for negative?
This.
You don't know it's, okay, that lines this up. Okay, so, what did you guys do? Not look at this, not look at this, just look at this. We did our little investigation where we had to zoom out and realize, like, yes, it is our biggest degree term that matters when we're talking about the ends. Now, when we're talking about the ends, we're talking about plugging in x's that are very, very big. And what we get are arrows to the left and to the right. Okay? Where our polynomial is going to end up. It's going to end up going to the left and up and to the right and down. Well, we are going to look at that with rationals. And you will find that, yes, with rational functions, you will have situations where your rational functions could end up, 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 down, just like you're used to. You could have arrows going ups and down. But what's different about rationals and polynomials is that we could also have arrows that end up going towards a specific y value, and they end up not going up, but going to the left and to the right at a specific y value. Cool? So we don't have to end up going like up, down, up, up. We could have this situation, but we could also have this situation. We could have a situation where at the end, we actually have our arrows go towards 0. So it's not just, you know, your touchdowns, your angry gorillas. You have like, I don't know, what is this? These guys, you know? Like, I'm flying. Yeah. What else is there?
In Rio. Scarecrow.
Yeah, you could bring in religion, but let's not. Let's keep religion out. Scarecrow. Okay, that's better, right? So yeah, we got other options. And the way we got to figure this out is actually use our knowledge of polynomial end behavior. Because let's say I gave you a different polynomial. And I said, well, this polynomial is negative 7x to the fifth minus, or actually, sorry, positive 7x to the fifth minus 20x squared. What's the end behavior of that positive x to the fifth, 7x to the fifth minus 20x? Okay, cool. So you know it's like, oh, I just care about the 7x to the fifth. Well, today, we are talking about rational functions. Rational functions are just polynomials divided by polynomials. So, if you understand that the end behavior of your polynomial on the top just worries about this, and on the bottom we just have to worry about this, when we're talking about polynomial end behavior, we can just care about this guy divided by that guy. What is this guy divided by that guy? Tell your neighbors. Do you remember how to divide things? So, this is important, guys. We are only not caring about this stuff when we're talking about plugging in our infinities. We're breaking back limits as x approaches infinity. When we're only plugging in infinities, we can cross other stuff out. And after we cross stuff out, we could simplify what we look at, we could realize that that's the same as negative 3/7. And guess what? If I looked at this very complex rational function, which is this guy divided by this guy, this is my end behavior. Which means we have one of these situations where if I go to the right and I go to the left, my arrows to the right and to the left will be located at negative 3/7. There and there. It's not up and down. It's not left and right. It's like, wait, it's not like ups and downs. It could be left and right. You know what I mean? All right. So what we'll have to do is really make sure we can divide some x's by x's. So like, could you take this and divide it? This is one thing you could do on your notes. Like, what is 10x over x squared? It's the polynomial on the top. We only care about the 10x. The polynomial on the bottom, we only care about the x squared. Divide it. What do you get? 10 over x. Okay, 10 over x. Congrats. That will help us understand our end behavior, but we have to look at that one a little bit longer because we're not sure what's going on here. What about this guy? Well, I would cross off the 1,000 because it doesn't matter when we're talking about end behavior and we're talking about infinities being plugged in. Cross that out. So you just divide x cubed by 100x. What do you get when you take x cubed and divide it by 100x? Good. You get x squared over 100, which actually means, oh, hey, that is my end behavior. I'm going to be up and up. You actually know that, like just by understanding the rational, you divide it, boom, I divide it, I get x squared. Oh, I know x squared's end behavior is this. So this is one of those situations you could end up having polynomial type end behavior. Okay. This guy, if the negative 1 went away and the 1 went away, and I just cared about 2x over 5x when I'm plugging in infinity, what do you get when you do that? You get 2/5. This is that type of situation. But there's one other type of situation, this guy. How do you get 0 for your end behavior? Well, flip over 2 pages. And let's look at the simple polynomial divided by a polynomial. X squared plus x plus 1 over x cubed plus x plus 1. If I ask you what's going on at the end, I ask you what is the limit as x approaches infinity of this function. First, tell your neighbors, what would you do first? We're talking about the end behavior, so what do we care about? Great. The biggest degree term, you ignore this stuff. It is important for all the stuff in the inside. Don't get me wrong. The vertical asymptotes, the holes, the zeros, very, very important. But when we're talking about the big infinities, you just care about x squared over x cubed. You simplify that, you get 1 over x. Okay. What I'm saying is that this polynomial's end behavior is the same as the end behavior of simply something divided by x. We have not looked at 1 over x before. We have not graphed it yet, really. It wasn't in last unit. So we're going to break out our mathematical minds, cold trick it. That's going on YouTube for forever. And we are going to think about what happens to the fraction 1 over x as we plug in bigger and bigger and bigger values for x. Tell your neighbors. As x gets bigger and bigger and bigger and bigger, 1 over x will get smaller and smaller and smaller till it approaches 0. This guy, my friend, whose end behavior will be determined by something divided by x. And if it's anything divided by any amount of x's, this fraction as x approaches infinity will approach 0. That means on your ends, your arrows are actually to the left and to the right at 0, not at a different number. Cool? So if I gave you this guy, h of x equals x minus x squared over x to the 5th minus 2. Make it x to the 4th minus 2. And I ask you about the ends. When I'm plugging in the infinities. Go. What do you pay attention to? What do you have to worry about? What do you get? I'm gonna pick on Linder here because he's trying to sleep. All right, hit me, Linder. What do we got? What are you thinking? You're gonna walk me through it. No, it's okay. We'll just talk through it. What do we got? So you crossed out the x and you crossed out the 2. Good stuff. You got negative x squared over x to the 4th. Great. Which you got as negative 1 over x squared. Now you think, oh, this is worrisome. I got a negative. And I got an x squared. Well, what happens? Negative 1 over 1. Negative 1 over 10. Negative 1. What happens as this is getting bigger? It's still going to approach 0. Now, you're probably thinking, but isn't it approaching 0 from the negative side of things? Yes, it is. But that sign and our approach from which side will be taken care of with our sign analysis. This negative 1 over x squared will have the exact same end behavior as 1 over x. If this was 1 over x cubed, if this was 10 over x cubed, if this is 500 over x, if this is 500 over negative 2x, it doesn't matter. It's going to approach 0 as your denominator gets bigger and your numerator doesn't do anything. We clear? Which means for that situation where you have a degree in the bottom that is larger, you will always end up with your arrows trending towards y equals 0. Bam, bam. At least we'll start there. In a little bit, we're going to do a full sketch and we're going to make sure we're approaching it from the correct side of things. Cool? But like for right now, boom, we know the arrows are going to be approaching 0. We are going to actually focus more on the larger degree next class, where we could have situations where our arrows look like polynomials. They could look like, up and to the right, up and to the left, down and to the left, up and to the right, all of those polynomial end behaviors. We actually could have that for rational functions. Like I graphed a couple earlier, just so you could see. Here we have x to the 4th plus 2x minus 5. You can see the end behavior is just like what we expect. It is up and to the left and up and to the right because we just care about the x to the 4th. The next one, I'm taking that polynomial and I'm dividing it by x squared. And we can see if I look at x to the 4th divided by x squared, which are the two things that matter, I won't care about this, and this. I just care about x to the 4th over x squared, which is the same as x squared. I can see it's the exact same end behavior, up and to the left, up and to the right as x squared. The next one I looked at goes to x to the 4th in the bottom, x squared in the top, and watch what happens. What do you expect this end behavior to look like? Tell your neighbors. Tell your neighbors, what does 1 over x squared's end behavior look like? It's going to go to 0 on the left, 0 on the right. There it is. Those are those arrows to the left and to the right. This one, ready? Challenge. I cross off. I end up with 4x to the fourth over x to the fourth. My arrows will go towards 4. See? It's not that bad. Okay. Well, let's see if you're picking up what I'm putting down. This guy. You think she's cheating? Should I check? All right, she's good. No. Good. But like, what does that tell you? Maybe draw something graphically so you know what that means. You get an answer. The answer is 1/3. Great. Show me you know what that means. Show me you know what that means. Show me you know what 1/3 means. What does that mean? Show me. Show me. Draw a picture. Draw a picture. Draw a picture. No, that's not right. No. This is so important. You guys got the answer 1/3, but you don't know what it means. Now, I'm zoomed in a little bit on the y-axis. Here is y equals 1/3. What we just did shows us where our arrows go at the end. You guys know polynomial end behavior. This is end behavior, but we're not going towards infinities. We're going towards y equals 1/3. In particular, to the right is what the question was. But if I looked in the other direction, yeah, it wouldn't change. It would still be y equals 1/3. You got me? What about that guy? Yeah, that guy. Show me you understand what you get. We are plugging in infinity for x. We're talking about the end. Y equals 4 is wrong. We get 4x squared plus some stuff. I don't care about the stuff. We get negative x squared plus some stuff. I don't care about the stuff. Did you guys spend time caring about the stuff? I hope you didn't. You get 4x squared over negative x squared. You divide those two, you get negative 4. What did you just get? The end behavior that y equals negative 4 is where our arrows go to the left and to the right. Now, we are not exactly on that line. We're going to approach that line, and we'll be a little bit more specific when we graph. You don't know that yet. Don't sketch everything. All I have is an arrow to the left and an arrow to the right. Don't worry about filling in the middle. We'll put it all together later. All right. No, go. One on the bottom left. That guy. Don't draw stuff in the middle. It's just arrows at the end. It's different this time. So what do you get?
3 over X.
Yeah, but what does that tell you? That your answer is actually not 3 over X. That's the answer.
0, right? On behavior 0.
That's the answer. Now show that visually.
Oh, visually. Okay, done. Just a plus with 2 arrows. Pretty simple.
Now for this guy, you have 3x over x squared, which you care about, which you then rewrite as 3 over x, which then you have to do a little bit of thought process. If I plugged in larger and larger negative values, the denominator is going to grow and grow and grow and grow and grow. The numerator is going to stay the same. This fraction is going to get smaller and smaller and smaller until it approaches 0. We won't care about if it's approaching 0 from the negative side or the positive side. That's what sign charts are for. We will then understand that to the left and to the right, my arrows to the left and the right are approaching y equals 0. Don't think you know what's going on the inside, though. Please don't put some stuff in here. Don't put stuff in here because you're wrong. This function does not necessarily, in the middle, look like 3 over x. Don't put that, it's like, oh, it's going to look like that. No, this 3 over x is what this function will look like at the end. The middle, this stuff matters. If I plugged in 1, that 1 and that 1 are going to matter. So don't think you have the sketch yet. We just have the arrows at the end. This is going to be the same deal. You try. Can we do better? All right, go. What? Yeah.
Yeah, because then I did that up. Thank you.
Yep. Do this one. Hurry. We don't have much time. Don't have much time. We got more stuff to do. Good. 4x squared over x cubed. This is 4 over x. This is negative.
No, wouldn't it be to the 4th? Because
It's just to the 4th. My bad. Which means this is x squared. My bad. It's different, but it's not. Thank you. It's different, but it's not. Okay? Because this will be what's going on for this guy's end behavior. But again, it's just the end behavior. You don't want to cross stuff out when you're looking at the actual graph. Only at the end, we look at this. As x grows, this is going to get smaller. This is going to approach 0. So we know our arrows are towards 0. Great. Now, let's put it all together.
Okay.
Ready?
I can't hear you.
Ready? Write down all the x's that are important. And label them as this or this or this. We're doing it all. Write down all the x's that are important. You got it. Caballero, you got it. Do it. Don't just copy down who's next to you. Next, create your sign chart. Go. We're not even talking about end behavior yet. We're going to do that later. Just do what you did on your quiz today. Do your inequality, your sign analysis of this y equals. Cool. Let's start. We do our signs. We have a no sign change at -1. Everywhere else will change signs. That's a positive, negative, positive, positive, negative. Okay. What's the end behavior? Good. If I multiply this all out, I'd have x squared over x cubed. That's all I care about when I'm plugging in infinity. This simplifies to be 1 over x, which goes to 0. Now, you are going to pretend there's a y-axis somewhere. Okay. Well, you know that to the left of -3, you have negative. Well, that means you are going to approach 0, but from the negative side of things. So I'm going to be just below y equals 0, and here is y equals 0. To the right, you know that you have positive values. Well, you are going to be approaching 0 from the positive side of things. You're going to be just above y equals 0. So you're going to get closer and closer to 0. You're getting smaller and smaller and smaller, but from a specific direction. Thank you, sign chart, for doing that. Now the rest kind of takes care of itself. Ready? Vertical asymptote, boom. Vertical asymptote, boom. Maybe you don't want to start all the way from the left. Maybe you can start in the middle. Okay, vertical asymptote. Let's use a blue guy here. I'm going to be up towards positive infinity to the left of it. I'm going to pass through a 0, and I'm going to be going towards negative infinity right there. Over here to the right of 4, since it's a vertical asymptote, I must be towards positive infinity. But then I'm going to trend towards 0. Imagine if you crossed everything out and not cared about anything. To the left of -1, I'm up towards infinity. I'm crossing through a 0, and then I flatten out and go towards 0, but from the negative side of things. You just sketched your graph. Let's do an easier one. You guys. There. I'm challenging you here. See if you can do this one. Sketch this guy. Because you need to practice. Because you've been slacking on your quizzes. Other people have.
Like the homework video yesterday was
So welcome to an AP class. All of my homework videos in AP Calculus are around 50 minutes to longer. Okay? You can listen to it 1.5, Linder. Oh, there you go. Yeah, it's good to be. Okay. Now, x equals 3 is a 0. X equals 4 is a vertical asymptote. X equals -2 is a whole. Okay. -2, whole. 3, 4. 3 is a 0, 4 is a vertical asymptote. What's your end behavior? What's your end behavior? 2. As you plug in either infinity, you'll have 2x squared over x squared. That will dominate things, which goes to 2. Okay, we are going to have y equals 2 be where our ends are. If you want to draw a dotted line, go ahead. I don't know if you have to. Okay. Where's our hole located? Actually, fill out the sign chart first. Fill out the sign chart. Positives at 5. We're going to change signs. We're going to change signs. We are not going to change signs at -2 because the multiplicity of that x plus 2 factor is 2. It occurs twice. Okay. One extra step is where is our hole's location? Find the hole's location, tell your neighbors. No, where is its location? Where is its y location? -2, 2? 2 times, if I plug in -2, I get 0. If I plug in -2, I get -5 over 0 times -6. These numbers close to 0 cancel. I get -10 over -6. I get 5/3. Now 5/3 is below 2. So boom, you got that. Now we have all we need. Positive infinity to the right, going towards y equals 2. Negative infinity, going through a 0, going through a hole, -2 going, -3 going through a 0. At -2, we have a hole that we pass through. This is a hole trending towards y equals 2. There you go.
Why don't you spell it at first and then ask them
Because it's not, it's a hole, Ryrie. It's a 0 over a 0. It's not a vertical asymptote, it's a hole. It's got a location. We found the location. 5/3. Now, to make sure you understand things, we ask you fun, different types of questions. Right, here we go. Asymptotes at x equals 3. Asymptotes at y equals 5. Answer these questions, go. I know. Go to ACL in a couple hours. I think I am, just because like we didn't show up last weekend, you know. Less than that. They cut the mics off. It was like 9:45 to 10:15.
Wait, were you there?
Yeah, I go both weekends. We go with the kids first weekend, and we go by ourselves, the wife and I. The second weekend has a better lineup. There's more people than on the study to see. 4 and 7. My daughter's been to 4 ACLs already, maybe 5. She's 7. Yeah, she went with the little babies, you know, yeah, put the little headphones on. Yes, kids under 10 get in for free. So it's like, yeah, we bring the kids along. All right, what's the answer? That's my son. He's 4. He has more fun than she does, actually. He likes to race, but then he passes out. But his glow stick lightsabers stay in the background. All right, what's the answer? No, what's the answer? Guys. This is what makes this class AP pre-calculus, because it's not like what we finish off as like a curve sketch and all we're doing is curve sketching. No, We make sure you really understand what we're doing. That's why we gave you the tables on your quizzes. Why you're given like the F equation and the G equation, we're asking you about like one-sided behavior. Like this type of questioning is the advanced type of questioning. What's your answer? Figure it out. X equals 3 must be a vertical asymptote. Since your y's are always positive, to the right of 3, you must be talking about a positive infinity here. Y equals 5 is a horizontal line, which means as I go to the left, that must be my end behavior. This is like next level. It's not just do the same thing over and over and over again. It doesn't involve any thought. This question will crush all calculus students when they have it on their calculus exam, and it'll crush you guys. Find A, find B, find C, given that we have a vertical asymptote here, a horizontal asymptote here, and a y-intercept there. And if you think that's going to disappear on you, it's not. If I plug in -3, vertical asymptotes are numbers over 0. If I plug in -3, I'm going to get 9 minus B. B's got to be 9. B's got to be 9 or else it's not going to make the bottom 0. If I plug in infinity, I should get just ax squared over x squared because I don't care about the c and the d. This has to equal 4. Well, a's got to equal 4. I just got that. I have a y-intercept 0, 2. If I plug in 0 everywhere, and I already know b is 9, c's got to be -18. Yes, it is. That's going to be on the quiz. And the next question. And all the tricky questions, because this is AP Precalc. No, I do not drop any grades because that is soft. No, soft. It is very soft. It's soft. You're soft.
I'm not going to be here next class.
Cool, good luck.
Thank you.
I hope you win.
Thank you.
I don't know. You forgot to tell me.
I did it, and I turned it in. I swear.
Did you turn it into that box? On the right?
No.
Well, see you later. I didn't type it in, so I never got it. You didn't turn it into this side?
Oh yeah, because we can go, but like, what about the big All
right, good luck. Good luck. Yes. Bye.
Yeah.
Okay, we'll just punt on it.
Or
You'll get the benefit of the 100 without the quiz grade. This is yours? Or any of these yours?
I looked at all.
You look through the first period?
Yeah.
Mr. Messer, can you just mark me absent today, and then I don't have
No. Stop saying that. Mr. Huffaker knows what he's